Hello? Can you hear me? Good. Well, welcome to this talk. My name is Tariq Madkour. I'm the Group Program Manager for the Visual C++ team at Microsoft. And I'll be talking to you about what's new for you as a C++ developer in Visual Studio 2013. I have been with the Visual C++ team for about 12 years now. And I've worked on the different parts of C++ from the compiler, the libraries, the code generation, the IDE, the debugging, and all parts in between. So I'm happy to entertain questions in the different parts. I have a very jam-packed session today. We did a lot of things. So I will try to go pretty fast. And I'll try to leave time for questions as well. So feel free to ask questions when there's time, as well as after the session. I'll also be here. Feel free to come by and ask questions. How many are C++ developers? Almost everybody. So you are in the right place. Good. All right. How many have been? How many are new C++ developers? Like started in the past few years. Okay. More than 5 years of C++ development. More than 10. 15, and I don't want to ask for age after that. Okay. So a lot of experienced C++ developers too. This is going to be great. Okay, so we have a lot of stuff to show. Before I start my session, though, I just want to just sort of share a little story, pay tribute to an old friend. That's Building 41. So for the 12 years I have been at Microsoft, Visual Studio has always shipped out of Microsoft Building 41, which is this little building here up in Redmond, Washington. And just this week, the Visual Studio team, after having spent all of this century in Building 41, is actually going to be moving away from this very nice building into another building, Building 25. While it might seem like, hey, you guys are just moving a block away, it's really not a big deal. When you've been there for 12 years and shipped all the way from 2002, 2003, 2005, 2008, all of them until this last release, this is going to be the last release we're actually shipping out of Building 41, so it's very special to us because it's, it holds a special part in my heart. But that's not the only reason I'm actually sharing this story. I'm sharing this story because we found a treasure while we were cleaning up Building 41. And it's a pretty cool thing. And that cool thing is actually T-shirts. Old T-shirts. They don't look old, but they are really old. Okay? So back, I want to say in the 2002, 2003 timeframe, when we were still called Visual C++.net. Anybody remembers that ugly name? Okay. It was a time I don't want to remember. But we created those shirts that had the picture of Einstein on them. And I don't really know if that's the real picture of Einstein, but the reason it had that was we used to, when we develop, we try to imagine the C++ developer and give him a name, and that sort of brings it closer to you. And we did the same for C# and VB, and I'm not going to tell you what their names were. But for C++, it was Einstein. So we had those T-shirts printed with Einstein on the back and Visual C++ on the front, and we gave it to everybody on the team. And that's a ritual we do every year. Every year we have a different T-shirt. My favorite one is one that said, here's a pointer, read programmers use C++. And another one was, my compiler compiled yours. But I don't have those T-shirts. What I have is this one. So in that archaeological dig, we actually ended up with 30 of those shirts that I have here that I'll be happy to give away to you if your size happens to be large, because that's the only thing I found. Okay? So throughout the presentation, I'm going to try to practice my throw. Let me see if I can do that one right. See how far back can I go. Not so far. Right. Well, I'll try to walk around. Okay. So we're going to do that throughout the presentation, just sort of a piece of exercise for me. So what are we going to be talking about? So what are we going to be talking about is basically why developers use C++. That's actually how I like to start. So we have this survey. Anybody follows our blog, the VC blog? Quarter of the people. Okay. Everybody else should. Okay. We have this really nice blog. We share a lot of information on it. And there's a lot of healthy debate going on. I'm just going to call it that. And often enough on the blog, we would just share a survey. We have we're having a debate internally about something. We say, why don't we ask our customers? So we share a survey. And we've been doing that for years. And we ask surveys about different things, but one of the common questions that we've asked every survey is, a paragraph, write down why you use C++, okay? And we track that over the years. So we've got like thousands of responses right over the years. And then we did a tag cloud of what are the words that come out most often. And that kind of helps us understand in your own words, without prompting, why do you actually use C++, okay? So here are the results. Well, this was not the title of the slide. It just happened to be what you guys said most, okay? Most people use C++ because of performance, right? There are lots of words for that, but really, performance stands out. These are all things for performance. Another one is compatibility. You want to be compatible with existing assets you have or existing assets in the community or some third-party library or something. We'll call that all compatibility, right? You want to be able to use... The beauty about C++ is that regardless of how much it has evolved, you can still compile code, mostly, that has been there forever, right? And yes, there are breaking changes, et cetera, but like it's kind of beautiful that we still have code. Our own compiler has code in the 80s, and we still compile, which is beautiful. So compatibility is very important. The last part is portability or cross-platform, depending on how you want to call it. People use C++ because it's one of the best ways to make tailored to the device applications, not just a web application that's generic, but a tailored to the device, written in a native language for the device, and C++ happens to be the one that you can actually use across, say, stuff from Microsoft or Apple or Google or other vendors that create devices, right? So these are top 3 reasons why people use C++. They also happen to be the 3 things I'll be talking to you about in terms of what we added in this release. What did we add for performance? What did we add for compatibility? And what did we add for portability? Now, we're also here at Build, and you want to know about what did we add for the rest of the Microsoft platform. So I'll actually start with, what did we do for Windows 8.1 tooling, and what does that look like for you as a C++ developer? And finally, even though we're Einsteins and we're the geekiest of the geekiest developers, and we're the ones that work with the hardest stuff, we still appreciate our productivity, and we still like to have a productive environment to work with. So what did we do for productivity? So these are the 0 to 4 things I will cover today. Okay, to start with Windows 8.1 tools. You saw in the keynote demo something about connected applications, right? You saw how Windows 8.1, we have SkyDrive built in by default. We have all this sharing between applications. Your application is expected to run in one place and then run in another place and be able to share data. Most of the stuff you sort of have a backend somewhere that you want to be able to connect to. And this is really not very easy to do in C++. So one of the things that we focused on for targeting Windows 8.1 is actually how do we give you a premier experience if you want to connect or share data between your application. So let's say, one of the most common scenarios is you have a tile, right? These beautiful tiles up there, this weather application. Excuse me. This weather application. How do you get this tile to update, to be live, to always tell you what the current weather is, right? You can't do this from inside the client itself. You have to write some service somewhere that updates that. And for me, as a C++ developer, when we were first talking about this concept, and like me writing a service, forget it. I'm just not going to do that. Let the tile be static. And then I learned how easy it was. But most people just never get over that first hump. And then we added tools in Visual Studio that make it super easy, and I'll show you that in a demo. And then I expect that a lot of people are going to start creating real good tiles for their applications just because we have this. Now, what are other scenarios that you want to connect to the cloud for? One is if you want to send push notifications. Your application is running, and then somebody else is running the application somewhere else, and you want to get a notification that says, hey, on Twitter, somebody followed you. You want to know that. How do you bring up these kinds of notifications? Or even better yet, you're creating a video application, and you want to save the position in the video, last video showed, and the position in that video, so that when you open it from another client, you can resume in the same place. How do you do that? How do you share? What kind of data in the cloud can you use that makes these scenarios easy, that you don't have to go and code yourself manually, okay? So we're going to talk about these scenarios. The way we make them possible for you in C++ is 2 things. Number one is, Visual Studio tooling, go add, push notification, do something. But the second one, it's really the core plumbing under it, is that we created a new library for accessing REST services in general, and then one on top of it, which is the one I'm referring to here, which is something specifically for Azure Mobile Services. How do you connect to an Azure Mobile Service and start communicating with it? So we're going to cover that. The other thing we did is, we have a number of presentation frameworks that are possible for you in C++ if you're creating Windows 8.1 applications. One is you can create a XAML application using C++. A second one is you can create a DirectX application. Who's used DirectX? Who's a DirectX developer? 15 in the room, okay. And who's used XAML? A few more, maybe 30, okay. So XAML is a very nice, powerful UI. It's a declarative UI that allows you to create some very nice 2D graphics or control-based applications in C++. It's 100% native using WinRT APIs. And it has a beautiful designer, much better than the normal designers we've been used to in C++. And this beautiful designer got even better, not just with support for the new 8.1 controls, but with new things like guidelines and rulers and dynamic markers and things like that. So actually, as you're dragging and dropping, we make sure that you follow the Windows 8.1 conventions and everything looks pretty and the spacing is right and all of that without you having to actually pay extra attention to it. If you are a DirectX developer, one of the hardest things to do in DirectX is actually to find out, okay, I put all these things on the screen and then it's not the color that I want. And what do I do? How did we end up not getting the graphics that I want? Because a lot of the stuff happens in the GPU and it's using shaders and using that weird things that are not actually C++. How do you debug those things? So we have this tool called the Graphics Debugger, or PIX, if you're familiar with PIX. And we made PIX better. So we shipped that in the previous release in Visual Studio 2012. And it was available in Visual Studio Pro, Premium, and Ultimate. So the first thing that we did this release is actually make it available in Visual Studio Express. So starting Visual Studio 2013, PIX graphics debugging is available in Visual Studio Express. Now, in addition to that, we went and added remote graphics debugging support. So you can be running something, say, on an ARM tablet, and you would be able to debug into that and look at how DirectX is behaving on the ARM tablet. We did a lot of work for compute shader debugging, for improving the performance, and a bunch of other things just to make PIX debugging better. On the theme of debugging, everybody was at the keynote this morning. You saw this pretty battery diagnostics thing. On that theme, we did a couple of things, right? So we did the XAML UI responsiveness. We took the CPU profiling and we sort of put it in the same shell and good UI that you've seen for battery profiling. So we have this new diagnostics hub that I'm also going to show you in the demo that allows you to access all these features. Not only that, for Windows Store applications, one of the themes that we focused on was actually debugging. So you saw async debugging. Now you can focus on just my code for excluding all the things that are in libraries or in compiler-generated plumbing. So you see nice and clean call stacks. We do things like interop debugging a lot better now, whether you have like a C# UI or a JavaScript UI and you want to interface with C++, so we have very nice interop debugging. Similarly, better dump debugging for ARM. So we added a number of things in the diagnostics area too. And finally, if you're using C++ CX to create, anybody uses C++ CX here? Who does? About 10, okay? So if you're using C++ CX, we did improvements in 3 categories. Number one is WinRT itself evolved. So following, C++ CX continues to follow and be primary on WinRT. The second thing is in the field of debugging from the API perspective. And last is performance, significant performance improvements for C++ CX too. Just making sure that C++ continues to be the most performant way of creating an application on Windows 8.1. So let me give you a quick demo of what these actually look like in action. Is it showing? Good. So this is an application that does face detection. Those of you who came in early to the talk, I was passing around with a laptop taking pictures of you. And that's where I'm going to use them. We're going to try to detect your faces and see if you're indeed human or not. If you're human, we'll detect your face. If you're not, it probably won't work. I think that's the reason. Huh? OK, so what this does here is, hey, let's detect some faces. You can go load image. We can look at everybody's images here. Say add. And when you open them, we just display them in this nice carousel control that I could just like swipe and move around as much as I want. This gentleman in the nice hat there is going to make it hard for us to detect the face, but we'll see. Hopefully it will work. Okay? So what we're going to do is, so the way that this application works is actually a combination of DirectX and XAML. This control, the carousel control, is a DirectX hand-rendered control. We move things, and we wanted to do things like changing the lighting and changing the speed and all of that, which you really can't do if you're relying on a generic framework to do the rendering for you. And then everything else, like text that we have here or the buttons that show down in the bottom, these are all XAML. So it's a combination of XAML and DirectX. So let's see what we can do with that application. So the first thing is we want to make it detect faces. Okay, I'll add a new button. There's meanpage.xaml, and there's the XAML designer. And in there, you can see that my page is pretty much empty except for the let's find some faces text. I can go and I can look at the outline, see the outline for the XAML, some of the improvements that we've made here. You can look at one of new Windows 8 controls, this app bar in the bottom, the command bar. We can go look at the primary commands. We have one command only here. We can add, which is the load pages. I can add another one. So let's add another command. Add an app bar button. Okay? Let's give it a nice name, detect faces. And just go to the properties and give it a nice icon. That's okay. Anybody sees a good icon yet? Here, maybe? Ah, I did the wrong one. Here we go. I'll just leave the icon. That's all right. And then I can do a click handler that says, and that's one of the things that we added to the XAML editor, is that now you can get IntelliSense in the XAML editor. So let's say I want to detect faces. Ah, see? That's throwing it off. Thank you. Well, I have the slash in the wrong spot. You get a shirt for that. So let's do click equals detect button click. Okay. So now I have the click handler. And I can even go to definition on that, like press F12, and I would go to the method that I just wired it up to. I had actually originally written that one. I just wired them together. And now you can see that the XAML editor pretty much behaves like a C++ editor, since you kind of refer to elements from C++ code back and forth, and you're able to jump nicely between both of them. I can build this one now and see what's going to happen to that face detection and if it's going to work or not. While I'm compiling here, you'll see a lot of warnings. And this is basically a Windows 8 application. And what you're seeing here are some deprecation warnings about some behaviors that changed between Windows 8 and Windows 8.1. So we give you warnings about those. If you are a library vendor, anybody here creates libraries as opposed to applications? A few. If you're a library vendor, that's another thing that you can add, is expose in your libraries if there are behavior changes between Windows 8 and Windows 8.1. For your library, you can use the same mechanism that we use to express those. All right. Yes. So let's try to detect the faces. Let's load the same images again. Okay, this is going to be the real test, because I have not detected those faces yet. Let's hope it works. Yep, we have all the faces we want. Let's detect faces. It's getting somebody. This is me. That was easy. I'm human. Yes. This is my friend Ali. Took a picture of him. It's finding me a lot of times. Apparently, I'm very easy to find. There you go. This is the guy who wrote the demo. And hopefully you can find yourselves in the next faces here. There's a ghost. There's a ghost. Found a ghost. I think it was right there somewhere. Anybody see yourself? Yes, it's real people. Okay, good. Oh, the guy with the hat too. Super. Okay, so it works. Okay, so the way that we actually detect the faces, we use an open source library called OpenCV, and we use that, and that's again like part of the compatibility for C++, is that you like to be compatible with existing libraries that are out there. If I want to detect faces, I don't have to reinvent that. I could just use something from out there that hopefully works with my compiler, right? So we try to always make our compiler compatible with all the things that people are going to use. All right. While we're here, let's say, let me show you something in the debugging part. Here's a, when we do the load pages and open picker, and when we wait for the picker to be done, and then in the resume for that picker, so this is actually an asynchronous operation, pick multiple files async, okay? And when that resumes, this block is the one that actually resumes. Debugging these things is actually pretty hard because you often don't know when you are actually here, right? What happened that got you here? And are you actually in an async operation or somewhere else? Basically, oftentimes you would break somewhere and be like, how did I get here, right? You want to be able to see a nice call stack. So let's see if we can get that. Okay. So now here, this call stack is actually a pretty busy call stack. I can see that I have the load button click lambda. So there's a lambda inside the load button click, which is where we are here. And then there's a whole bunch of stuff, callable object, func_impl, func class, concurrency runtime, et cetera, right? So it's kind of hard to find out where you actually are. So one of the new things that we added in this release is, oh, actually, one of my favorite features, Control Q launch bar. Everybody knows this one? What did we want? You could just write something here up top, and then hit enter. And it takes you to that, because I can never find my way in tools options, and now I can. So I just Control Q, type whatever it is that I want. Actually, one of the really cool things, who was at the what's new in the Visual Studio IDE talk before this? A few people in the room. Okay, well, everybody else didn't see this. See this tools options? It's now resizable. How cool is that? This is awesome. You know what else is resizable? Project properties. This is resizable too. There you go. Yes. All right. So we do all that work, and this is the one that counts. Okay, let's go back to tools options. And there's this thing here called enable just my code. If I check that and press OK, look at what happens to the call stack. The call stack is all of a sudden relevant. And now you see, OK, I'm in some lambda somewhere. Yes, thank you. I'm in some lambda somewhere. And then there's a whole bunch of external code that you probably don't care about. Maybe you do. Sometimes you do. You want to debug into our stuff. That's why we should source for it. Then there's an async call. So now you know that there was some async there. And that's where you came from. So you're in the click handler. An async call happened. We went into a bunch of Microsoft C++ code. And now you're back into your code. And now your call stack is actually relevant. Is there an easy way to toggle it, or do you have to go back to the options? That's an excellent question. There doesn't seem to be a very easy way to toggle it. Put it as a request for the new release. You know, one of the beautiful things a gentleman was just telling me. Oh, there you go. I didn't even see it. Your wish has been granted. What else do you want? Okay. Ship, that's nice. Okay, so let's go back to the show external code. Thanks for finding it. Who found it? Ah, there we go. You want a t-shirt? You got it. So, all right, so we're done with this debugging. The other thing that I wanted to show is you go here and you go to debug, and you go and say performance and diagnostics. So this is the new diagnostics hub. And you open that, And you get all the things related to diagnostics in one place. And you can click a number of them or one of them. Some of them are compatible with others. Let's say, I want to see the UI responsiveness for this thing. And you say start. And this basically starts your application in that debugging mode. And then when it's done, it generates a nice report that has a collector that it has to run in admin mode, obviously. So let's detect some faces. Is this separate from the profiler? This is separate from the CPU profiler. It's a different kind of profiling target. But you don't have to re-instrument, like if you're familiar with like instrumenting, to have to instrument for the profiler, you don't have to do that. This is based on ETW traces. Yep. Okay, so we do that. Well, let's go back. I'm going to draw some stuff on the screen. And we can go here. And it can say stop collection. Just in a similar way when you saw in the keynote how we did the workflow for the battery profiling, like how much power usage you're doing, exactly the same workflow, and now you get XAML profiling. Now, it of course happens to be here that for my current application, it's all custom rendering. This green is custom rendering. What's actually consumed in the runtime is that little red stuff there. But all the green is custom rendering every frame. That's because I do a lot of DirectX. And this is really more for XAML, not for DirectX. Maybe next time we get more for DirectX. Okay, let's stop profiling. Let's see if I can get back to my slides. All right, so that's what we did for Windows 8.1 applications. Now I said we're going to talk about performance, compatibility, and portability, right? For performance, before I go into details of what we did in performance this release, I want to talk to you a little bit about performance that you already have with compilers that you're using. Who is using Visual Studio 2012? More than half the room. 2010. Like 40%, okay. 2008. Somebody's been raising their hand the whole time. Writing a library? No? 2008, a few, okay. 2005? Fewer? 2003? Come on. Somebody has their hand up. Okay. Visual Studio 6? Ah, 2 people. Ah, but VC6? No, you're breaking my heart. Any of you have a t-shirt? I'll take it back. Okay, so we collect telemetry from our customers when they go and say, like, sign up to the customer experience program, right? And when you do that, we get some data, anonymous data, about which parts of the product you use more and which parts you use less. And that kind of helps us to know which areas to focus on. And there are some free optimizations that are available ever since Visual Studio 2005. So all of you have them, except for the couple of you who only raised your hand on VC6. We should talk. So there are a number of optimizations that you already have. There are some that, instrumentation tells us that most of you use, 99% use, and there are some that very few use. So just want to make sure that you're all aware of what existing optimizations you have before you start learning about the new ones. So the first and most straightforward, which 99% of you already use, is just compilation unit-based optimization. This is when you throw the /O2 or O1 switch to the compiler. And the way that this works is, we get 2 CPP files, for example. We compile each of them separately. We optimize each of them separately. So CPP1 generates its own OBJ that gets optimized separately from CPP2 that gets its own OBJ that gets optimized separately. And then the linker goes and mixes those 2 things together, and here you go. You have an optimized binary. It's not bad. It actually does a pretty decent job. The difference between a debug build and this kind of optimized build is significant, right? But then we added this thing, which 100% of you should be using, but only 90% of you are. So those 10% I want to find and make sure I'm on a mission to convert you to make sure that you use them. It's actually a default. If you do file new project, it's a default. But if you had an upgraded project, let's say, for example, you're in VC6 and you had this library that you kept moving forward, and you never went and changed the build options for that one, it maintains its old build options, so it never gets the new optimization switches on it. So go back. If you find one of those things that doesn't have /GL and /LTCG, just go throw it. It's almost free. Depending on your scenario, our typical case is about 10% performance boost that you get for basically. Hmm? I can't hear you. Does this apply to DLLs as well as EXEs? Absolutely. It applies to DLLs and EXEs.
We do like do a relay for an incremental build, and we use whole program optimization. It takes a long time.
Right. The gentleman here is pointing out that it takes longer to compile your release builds if you set these options on. That is absolutely true. There is a trade-off in that it's going to take longer for your release builds. It doesn't affect your debug builds, obviously, the ones that hopefully you're using all the time. But release builds, it will add some time. It will actually add some good chunk of time here. But the end result is really, really good. The way that this one works is we do the exact same thing that we did before, except that when we link these OBJs together, we do a bunch of extra optimizations. So for example, on the first part in O2, one of the common optimizations is if function A is calling function B, function B is called from A 99% of the time, we just inline them. You say, hey, you don't have to execute that as a function call. Just get the body of this function, embed it in the body of this function, and we're done. Call it a day. And then that actually saves if you're, say, calling this in a loop. What this does is if these two were in two different CPP files, it can do the same thing, right? It wasn't able to do that here because it never knew anything about other CPP files. Now you can have, a function from one object calling another function from another object, and they can get in line too. And now you have a more optimized binary. And the last one, and that's the one that in our numbers, somewhere between 8 and 9% of you use it, is profile guided optimization. And this is everything that whole program optimization had, plus it adds the ability not to just look at the whole program, but also run your program through a scenario that you actually care about the performance of. So you take your app, after you compile it with LTCG and you have this optimized binary and everything, we instrument it somehow when you put the LTCG PG instrument option, and then you take that instrumented binary and you run it through a scenario. When you're done, link it again with LTCG PGO. And we'll use whatever information we collected during that performance run and use that to optimize this scenario. This is a use, be careful when you use it one, because if you start running it, for example, into your test cases and error cases as opposed to the ones that you actually want to make faster, all your exceptions are going to run faster and all your failures are going to run faster, but your app is going to run slower, right? So you don't want to do that. Just make sure if you have clear performance scenarios that you have for your application, this is one of those best things. For example, SQL inside Microsoft, right? We have very clear, TPCC numbers that we want to get. So very, very clear scenarios, insert and add and sort and these things. We build SQL, we run it through those performance benchmarks that we want to make sure we optimize for. The binary coming out the other side is 30% faster, okay? 30% faster over this, which is already 10% faster over that, which is already like 100% faster than debug build. So it's a very nice progression. There's a question, yes? Does this apply for compiling for Windows CE? I am not sure about the answer to applicability to CE. I'm more focused on desktop, but I can find out. I think not, but I'd like to find out. If you see me after the talk, I'll give you my card and just follow up with me over email. Can you do this in the GUI now? We've been doing this, but we've been doing it through command line tools. Yes, you can do this in the GUI. Yes. OK. So what did we add? So this is what you had. This previous slide, what you had in 2005, and we made it better in 8 and better in 10 and better in 12. It's roughly the same methodologies, right? In 2012, we went and added automatic vectorization. Who knows about automatic vectorization? Few, OK. So automatic vectorization, see on your CPU, there are these things called scalar registers, and then there are vector registers. Scalar registers are like that wide. They take like a one number, one int, or one thing in it. And then you say, put one number and one integer say in the register, another integer in the register, add them. And if you have a loop like this one, you go 1,000 times. Every time you're loading one thing in register, loading another thing in register, adding one time. CPUs now have these vector units, and these vector units can say take 2, 4, 8 of these numbers together in one register. And then you can do one add. So you can load 4 of them in register, 4 numbers in register, 4 numbers in the other register, and do one add. Okay, so you can add them 4 at a time instead of 1, 2, 3, 4. You do 4, 8, 12, 16. It goes significantly faster. And you kind of would have expected the compiler should just do this for you, so that's what it does now. We detect cases where we're able to automatically use the vector units, and we just do that. So just by recompiling with Visual Studio 2012, we'll look for places where we can use automatic vectorization, and we will. Which for all modern CPUs basically makes your app run faster. 2013 looks for more cases to automatically vectorize and do other optimizations. One of my favorites, for example, is this permutations of a perfect loop nest. So you have a for I equals something, and then nested inside that for j equals something, and then you access a sub I and j. Okay? Well, depending on the order of things in memory, you may be accessing them in sequence, or you may be accessing them in strides, skipping, 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 and then going back and skipping, skipping, skipping. We detect that, and we fix it for you if you were doing it not the way you were supposed to. So now you don't actually have to keep thinking about how your array is laid up in memory, and we just automatically optimize for that. Another favorite of mine is, statement level vectorization. That's actually interesting. So instead of just vectorizing loops like that, we actually look at specific statements. And statements where we say, hey, there looks like 4 additions right next to each other here that we could actually do, or 4 multiplications. Let's put these in vector registers as well. So we try to find that. Most important one, in my opinion, is where we do the pointer vectorization. So things that are actually based on pointers. So instead of a straight line, there's an index variable and it's increasing, monotonically increasing, we look at pointers, and we do the pointer math, and we can verify some things during compile time. And if we detect that this is something that can actually be vectorized, we do it. Why is this important at all? Because that's how something like STL is implemented. It's all pointers internally. So code like the top one here, the transform function in STL, for example, is going to has code that looks like this, right? Now we can actually vectorize that code. We can do exactly the same thing as if it was a loop with a normal stride. Okay, does this support the latest Intel instruction sets, or is this up to a certain level? So this is a generic question. The generic answer to that one, no. There's, Intel continues to add things in their compilers, and AMD does, and ARM does that we don't. So we continue to do. We use SC 4.2, I think is the what we use. 4.1 and 4.2 is what we use. Yeah. Good question. So the question is, does your code break now when you run it on an older processor? Actually, not. So one of the things that we do here is we always have to access the odd case. So like if your number were not a multiple of 4, we always branch out to the last one is handled by a collector at the end, right? Like the last 3. So we just detect and we automatically go to the collector at the end. So it actually runs just fine. So we did a whole bunch for automatic vectorization. One other thing that we added is something called the vector calling convention. And the vector calling convention is if you're doing a lot of vector math, say you're doing like DirectX or some heavy computational math, and you are passing these things between functions, what happens is, because we don't know how to use vector registers as ways for passing parameters, we always push things on the stack. Now we don't. Now if you can tell us that something uses a vector call, we will automatically go and say, oh, this guy can actually be passed. This guy can actually be passed on, in a vector register. We do that, and this function, for example, here, stack allocation goes down to 0. We used to allocate 64 bytes for this. We don't do that. Similarly, the instruction count for how this works, instead of 16, I think we go down to 5. Right? So we detect cases like this, and if you say vector call, we'll actually make use of vector registers while doing the calling convention things to call into the function. We use this vector call to actually get DirectX to run about 15% faster in this release. The last one is C++ AMP. How many people are familiar with C++ AMP? Few. Oh, more of you should know about C++ AMP. So one of the coolest things about the latest evolution in hardware is that it is no longer just the CPU, right? There is heterogeneous hardware coming out there. For example, GPU. And those GPUs are capable of doing a lot of things, especially things related to mathematics and computation. So in the past, to be able to run code on a GPU, let's say you had those GPUs are really good with handling matrices and numbers and multiplications and things like that. let's say you had a video and you wanted to decode a video, or you had a face and you wanted to be able to detect a face in an image. That's basically doing very advanced mathematics. You can do these things are very well suited for the GPU, except that now you need to learn a whole new programming language to learn about how to offload things to the GPU. And then you have to deal about the different vendors, and multiple vendors have their own ways of dealing with their GPUs. So you might write code just for NVIDIA or for a AMD ATI or something, right? And now with C++ AMP, you can directly write C++ code that is going to run on the GPU. Okay? You could just write a normal function and say restrict AMP as a decorator for that function, and then the code inside that function. There are some restrictions about what kind of C++ you can use there. But generally, you're writing C++ code, and you're just adding one word that says, please run this on the GPU if it's available. And we do that for you. So it's basically a programming model for accessing those heterogeneous devices. And we started with the GPU as the first device that we're accessing for that. And it's very nice because it's modern C++, and we use like STL-like containers and algorithms for dealing with it. Visual Studio 2013 adds some really cool things. One is it adds the ability to share, to zero copy, like to copy, to eliminate and reduce copies in architectures where there's actually shared memory between CPUs and GPUs. So we actually detect those cases and make the copying happen faster. Another thing that we do is that we have texture support, and we enable the debugging all the way down to Windows 7, which wasn't possible before. So that's it for performance. Next one is portability. Okay? And for portability, for compatibility. And for compatibility, the way we look at this is basically what is the C++ code that should actually be able to run, any library should be able to use, or you should be able to run across any platform or any of that, right? And the way we look at that is basically how ISO compliant are we? So how many people are using C++ 11 today? So about maybe 10, 20% of the room, okay? So one of the new things that have happened in the last 2 years is that we have a new standard of C++, C++ 11, and Herb Sutter has a session on Friday where he's going to be talking about not just C++ 11, but C++ 14, the upcoming standard next year, and C++ 17, the one after it, and what our team is actually doing about those as well. But I'll just focus now on what we did this release for the ones that we target. So we look at our C++ 11 conformance. I'm not going to say a whole lot on it because we did quite a bit in this release, and if I were to fit all of what I have now and the C++ 11 talk, they probably wouldn't fit in just 1 hour. So we have a whole hour where Herb is going to be talking about what features of C++ 11 we have supported, what features still remain, what is our plan for the ones that are remaining, and how we get them. I'll just say something very short so that you don't keep waiting until 2 days to figure out what the story is. We shipped a CTP in November, last year in November. So obviously everything that's in that CTP rolled into this release of Visual Studio 2013. There are a number of new features that we've added as well. Herb is going to talk about which specific ones we added, as well as a number of other features that we added that I think as C++ developers you're going to look at and say that we continue to move it forward. But I'm not going to go into a lot of details into C++ 11 in this talk since we're not going to have time to cover everything else. Okay. Portability. So portability, we look at this is very related to compatibility in that you expect that your code is going to be able to run against any existing code that's out there. You can consume any existing code that's out there. But part of that is also that it can run on any other platform. And when I talk about cross-platform, I'm talking about the generic sense of cross-platform, not just cross-Microsoft platform, phone, and Windows, etc. I'm talking really about Microsoft and other vendors who have C++, and you expect you to write C++ applications. So when we look at that, we think that part of how we can move portability forward is actually to look at libraries, right? A number of libraries that we create, they really fall into one of two categories. They're either libraries that are specific to the Microsoft platform. For example, we're doing a library to access Azure mobile services, right? It's a very Microsoft-specific thing. Or we're doing libraries that are generic. They are things that you want to be able to basic building block of your application. And those generic libraries, we expect that they should be available and portable everywhere. So we have this new move within our team where we are looking at what libraries is C++ missing? As a C++ developer, one of the best things that you have is that you can use any C++ libraries out there. One of the worst things that you have is that there are a million C++ libraries out there. So this is really good if you're doing, any niche thing and you want to find a library for it, you will find something. But what if you're doing something really basic, like, communicating with a web service or parsing some JSON or parsing some XML? Do you really have to go find 10 different libraries? There are some libraries that are going to add unique values in some places. But for the generic case, you really have to go figure out a ton, which library to use and is it compatible with the rest of your stuff and has it moved to the right version of Visual Studio that you have? So we want to fill in the gaps with some of these libraries. And when we look at these libraries, we want to write them in a portable, cross-platform way and push them such that other vendors would have them too. So we started in this release with what we call the C++ REST SDK. And the C++ REST SDK is basically a way for you from C++ to communicate with RESTful services, whether stateless or stateful services. And this is generic or agnostic of anything Microsoft. It's not connected to Azure or any of that. This is just a generic. You have a REST API somewhere, Facebook, and you want to be able to consume that API, you can easily do that from this library. It is written using modern C++ 11, very nice C++, elegant C++. And the last is actually, it is open source and cross-platform. So we released this as an open source project called Casablanca. Anybody heard of Casablanca already? Some have. Okay, that's good. So we released this as a Casablanca project, and now we're going to be adding a snapshot of that current state of the open source project and putting it inside Visual Studio. We're going to continue to innovate in that as an open source project, and we have ports for other platforms. For example, right now we have Linux, and we have people working on other ports as well. And we're going to continue embracing it as an open source project. And when we look at future libraries that we're going to create, if they're not specific, say, like to Windows 8.x or something, we're going to try to create those as open source generic libraries. Right? Does the REST SDK have WebSockets support? So the REST SDK has an HTTP client that allows you to do get responses. It's actually a good segue into my next slide. So we have an HTTP client that basically allows you to do like get requests and things like that. It also has a JSON parser. And it has like a streams library so that you can handle what you're getting as a stream, read stream, or a write stream. And that's what it has now. But we continue to build on it. So WebSockets is an interesting one. And you can actually go and get Casablanca.codeplex.com and start looking at it today if you want. Yes, there's another question. The question is this HTTP client independent of the platform, or does it use WinRT APIs? So because we're creating this as an open source library and we're actually creating multiple ports for it, obviously on Windows we'll use the best thing available on Windows. But we also have ports for other platforms that are not specific to anything Windows. So the idea is that you are able to actually use this HTTP client. So let's say this example, upcoming example. Here's an example of the HTTP client, right? You're trying to access a MyHTTP server with a GET. And what you're doing here is you have this client, you created the HTTP client, and you're going to submit the request, which is a GET request. And you say when that request is completed, so this is going to run asynchronously. So the minute this line terminates, you're, after that line, executing things here. When this is completed, you go inside this Lambda body, and you start performing these actions when actually the server returns to you with information. This is generic, runs on any platform. And yes, on Windows, we use some Windows-specific things, but on non-Windows, it works. And the reason we think these are important cross-platform things is that when you're doing web service communication, you're typically not doing that only in your UI. You could be doing that somewhere in your, in your model as well. And you want to continue to have your model portable across platforms. We try to provide you with a portable API for that. The question is, do you use PPL for the asynchrony? Yes, we use PPL for the asynchrony. PPL is a parallel patterns library, and the kind of .then is a giveaway for that, is the continuation pattern for the parallel patterns library. And it's one that allows you to create tasks and schedules, a new thing that we added in Visual Studio 2012. Happy to talk to you about it if you don't know about PPL after the session. There's a lot to use there. It's actually a beautiful library. Here's sort of another example, sort of more complicated. It shows not just the HTTP request being sent, but also JSON coming back and you doing something with that JSON and parsing the JSON. Very nice C++ API that you can actually use and you can use cross-platform. It's one of my favorite things that we added in this release. So I'll actually skip the demo here because I only have 10 minutes to go and I want to show the rest of the productivity stuff. But the idea is in your code, you could just be able to use the HTTP send. And I had a demo where I was showing connecting to Facebook with these photos, and I was going to post your photos on Facebook, but I'll spare you that. All right, so the last thing I want to do is productivity. I was just talking about libraries. So the first thing we did for productivity is actually related to the acquisition of libraries. C++ is beautiful because it has 1 million libraries. Now we're making it easier for you to acquire a library. One of the things that really kind of irked me is that every time I want to go use a library, I go figure out what's the include path, what's the lib path, where do I put it on Visual Studio, how do I share it between the different machines, do I check it in or not, did I set it in every project, do I set it per machine? It's kind of confusing. So we had this NuGet thing that we were using in Visual Studio, and now we made support C++, where basically if a library vendor, so the library vendor would actually have to go and expose their library that way, and currently only these 2 libraries exist, the ones that we just created. We're seeding it with that. It's actually very easy for a library vendor to go and say, here's an little XML file and a couple of configuration, add it next to my library, and now we can see that as a NuGet package. And for you as a developer, you go open Visual Studio and say, manage NuGet packages. You see a whole list of NuGet packages that are actually available, and you check on it and say, install on my machine, and now you have it. And from your project, you could just say, add reference, NuGet the REST SDK or whatever package you want. And it becomes very easy. No more futzing with the paths or anything like that. So it's a very nice thing. If you're a library vendor, the 10 of you who were, please start populating that list. I'd love to see more than 2 things in there. And I'm hoping that next year when I'm here and talking to you about it, we're going to see a lot more libraries that are actually consumable that way. The rest of the IDE enhancements, I think, are better done through Visual Studio. So we'll skip any slides and go directly to Visual Studio there. All right. Good. So my favorite feature in Visual Studio, and this is one that we did not add this release, we added in the one before, but I know that not everybody uses it yet, is control comma. We kind of changed it a little bit in this release. And this is something that allows you to find any symbol, file, anywhere in your solution by just typing its name. So you do control comma, shows you a little window up there. I'm going to type the Facebook. Okay, and I see facebook.cpp, facebook.h, the Facebook client, the Facebook click button, all of that stuff, right? And you could actually go to them, enter, and you go. And this is one of my favorite features, and I keep repeating it because I know not everybody uses it, but it's just the fastest way. Control comma, foo.cpp, enter, you're there. The other thing we added is that, notice this scroll bar here? One thing we added is if you go to scroll bar options, you can use this really nice and big scroll bar, which actually shows you a view of the source code of where you're at, right? Not only that, it's actually pretty cool because, let's say, I go somewhere here. Let me open this file. This has more stuff in it. Let's say, I'm searching for something, app, right? Now in the scroll bar, you can actually see in this yellow all the places where it actually has symbols for it. Let's say I added a breakpoint here and, well, there. You can actually see the breakpoints as well. So you had an error. Okay. Instead of activate, I'll call it no activate. Okay. So now you can actually see the red squiggles of where you have errors, and you can go there. You could actually, while you're hovering down, you can see a quick view of the source code. One of my favorite features as well. Just how do you quickly see a big visualization of your source code? And for people who have long functions / long files, it's a godsend. It is not on by default. By default, you see the small version, but I actually like to operate in the big version all the time. The other thing I like is something called peek to definition. So we always know how to go to definition, but now you can actually go to definition in line inside the file that you have. So you could just go do Alt F12 or select peek definition. And in peek definition, you just see the file directly here. And you can move around. You can even search. You know, search for a graphics engine, okay? And in here, you can peek some more within the same file. You can keep moving. If you had a wide scroll bar, would it show a wide scroll bar? Yes. And you can keep moving, and you know, I don't know, something here. I can peek to that one as well. I can keep going down. Let's find something interesting. Here we go. Peek to that one as well. And now you have a breadcrumb of the previous things that you've peeked at. Next. You like this one, you can go promote it to a real tab and use it, or you could just hit escape and it's gone, right? It's a very nice way of peeking into the files and just understanding source code. Yes? Are the references above the functions?
Yeah, the metadata about.
So you're referring to something that you saw in the other demo the other day. Yeah, so there is a feature in C# called CodeSense, which kind of shows you some metadata about the functions. We don't have that in C++ because it really relies on some metadata included on the functions. Yeah, no, we don't have that one. Okay, so you can do a quick code peek. You can do a move line. So let's say here, I'll just try to insert a line here. All right. And let's say I want to move this up. I could just do Alt up and move it all the way to where I want it to be. Okay? And I can move down here, and I can start adding code. And if I am in an event handler, I can do this, and it will automatically generate the event handler usage. And now it's going to decide, hey, I don't have on exiting as an event. I can press tab, and it's going to create it for me. So now it went and created the on exiting method for me. Not only did it do that, it added to the header and CPP. We also now have a very quick way of moving between headers and CPPs, which is toggle or Control-K, Control-O, and takes you to the header, back to the CPP. My second favorite feature in the whole IDE. Hey. All right. Another thing that the last thing that we did actually that I want to show today is one of the most beautiful, which is code formatting. So this is I just opened a random file on the disk that I want, has some demo code in, and you'll see the file has inconsistent formatting, lots of spaces before the braces, sometimes a space before or after the colon here, no consistency on this, sometimes a space, sometimes not. The indentation is not always right, things like that. Now, if I take this code and actually try to paste it in my project, it goes and is pasted beautifully formatted. Now, it's not just beautifully formatted, it is beautifully formatted to your specifications. So you tell me how you want to format that code, and we will format it for you. So here's how we do the indentation. Where do you want the new lines to be? You want the open braces to be on a new line or on the same line. Similarly for types. What about for functions? What about for these things? How do you want it to be? It doesn't do that only on pasting, but it does that also on typing. So let's say I had here, I equals I plus 2, semicolon, puts it out. And you could just set it basically to any kind of formatting that you want. The tools options page shows you a preview of the formatting that you actually have so that you can select exactly and see what it's going to look like. Yes?
Can you do a select all on existing code and reformat correctly?
Can I go select all on existing code and reformat correctly? Absolutely. So you could just say, I'm going to mess this up, and I go in here and do Control-K, Control-F, and it starts looking beautiful. does it do the thing where if you close a brace, it automatically formats everything that's inside it? Well, it automatically is formatting as you're typing, so you don't need to do that. But we do this really other thing, which is here, you can do class, my other class, and notice that we now generate the braces for you automatically. And you click enter here, and now it's in the right spot. You can start doing a function into my fun, and then it has that. And it also notices when you type, so it actually does the type over. So it does automatic full brace completion as well. All right? Can you export your code formatting so that you can all use the same standard? Yes, you can export the code formatting. You can go to Tools Options, and there is Export the Options, and it creates a VS Settings file that everybody can then use. All right. And I can go back here to my slides. So that was really it for the enhancements. We talked about code formatting, showed the header switching and the brace completion and the code peak. We enhanced the UI for code analysis, so you can actually now see categories for code analysis for the errors and do some sorting and things like that. I talked about async debugging and just my code, which are some of the beautiful features. And we do interop debugging not just for JavaScript and C#, but also now for Python and for GPUs. So if any Python users? Few? Now you get Python and C++ interop debugging as well. And that's it for my session. I'll come to your question. There are a number, this is our blog. This is the one that if you're not following, I'd really love if you follow it. You'll find a lot of great information there. Our Developer Center has basically all our things that are valuable for developers from an MSDN perspective. And these are other sessions, especially Herb's Future of C++ session on Friday at noon that you should make sure that you are at. There is a team, a usability team, a user research team from Microsoft that is also here on site. They collect information from you so that you can help us make our future product better. If you're interested, please email them. They would love to meet with you on site. And finally, please evaluate the session. And I have a few minutes for questions if you want. And meanwhile, I haven't been doing that, so maybe I should. And Sridhar, if you want to help me too. Somebody should do this for the back. Here we go. So, who has questions? Yes, I'll start with your first question. Sorry, who has a question? Raise your hand if you have a question.